Cool. Hi, everyone. I'm Nitin from LinkedIn, and here is my colleague, uh, Prasanna, who joined us from Netflix. We both worked at LinkedIn. Prasanna recently moved to Netflix. So today we would like to share our work on how we personalize the performance of LinkedIn.com. Uh, So at a high level, we'll talk about a little bit of about LinkedIn.com, what it is, and where we use it, and how we personalized images on LinkedIn's feed page, the home page of LinkedIn, using two approaches. One using NetInfo, and what was our experience using NetInfo, and then how we solved those challenges using our own service that we built homegrown, something called as performance as a service, in short PaaS. And finally, we would like to inspire you all on how we can personalize performance going forward in this direction. So LinkedIn Lite is a mobile web offering of LinkedIn, and it is designed to be performance first in the way of its making. So it is completely like rolled out to all the global members of LinkedIn.com whenever they log in to LinkedIn on their mobile web. It's a different app when compared to a desktop app, and their goals are very strict. So they want to load all the pages of LinkedIn on a mobile web under 6 seconds, 90 percentile of them. And all the testing they do is completely on 2G networks, and it is a server-side rendered application. If there is a link in the notes section which talks a little bit more about this architecture of LinkedIn Lite, and this is the app that we use to test our uh, experiments of personalizing performance on. The first experiment that we did on Lite is adapting the image resolutions. So as you can see here, there are two images. One is a lower resolution and other is the high resolution. LinkedIn Lite, as it was designed to work for everyone globally, default chose 400 pixels just so that the experience is smooth. Regardless of their network connection. But they wanted to experiment with 800 pixels images or double the size for people who can, let's say, afford it. They have good network quality and good device quality. So they, uh, yeah. So, but why did they want to do this? I mean, the reason is pretty obvious. Images play a very big role on feed, and they're mostly images and videos on feed. And they really drive engagement. And we have seen this several times in the past that whenever we have optimized images, the engagement really shoots up. So overall, like the metrics that we care about around session engagement are really driven by images, and that's why LinkedIn Lite was interested in optimizing images. And so the first approach they took was to use the on-device measurements, or like the NetInfo API, which directly gives uh, a classification of four classes, like 4G, 3G, 2G, and slow 2G. It uses on-device measurements like RTT and throughput to come up with this classification. So LinkedIn Lite used this API to only give high-quality images whenever the network connection was 4G. And this is how they did it. So the client requests LinkedIn Lite website uh, by going to linkedin.com/ on their mobile web app, and it sends both the request as well as the netinfo information. And the server side, like Delight, uses this information to do something called a quality classification. Like does something like, okay, it is 4G, so let me. It's a very simple if and else condition. If it is 4G, then let's go and ask the image provider, give me a higher resolution image. Otherwise, let's use a lower resolution image. So at a high level, this is how they do it. Like everything, the decision making and also the uh, result of what image URL to use is completely on the server. So nothing happens on the client and they return the feed page. So this is the server side rendering aspect of LinkedIn Lite today. And the results were quite promising, and this is what we got after rolling out using NetInfo on-device measurements. Uh, Feed viral actions, what it's a very important metric at LinkedIn, and this drives engagements like how many clicks, likes, shares, and all that types of actions which uh, drive more people to use LinkedIn feed. That improved by 0.11%. It's pretty hard metric to move unless until usually we add new features. These metrics move, but just with changing the image quality, we were able to see these gains. So it's quite impressive. Similarly, I mean, as the name says, it's the amount of content that is shared that also improved a lot. Probably people are able to engage with the images more. They like the images, so shared more. So these are all pretty good. NetInfo gave us a very nice, easy way to try our idea, our hypothesis, and we also got some good results. However, there are some small downsides. I think that's what we mainly wanted to share today and how we addressed them. First thing is a pretty obvious one. I think the browser support of NetInfo is only on iOS. Sorry, is only on Chrome, Chromium-based browsers, and iOS is a big share for us, and there is no support for that on iOS. So 50% or so of our members cannot even have this optimization. And secondly, one other small drawback that we saw is 80% of our requests are marked as 4G. So this is quite shocking to us. I think if 80% of them are marked as 4G, we cannot do much about like finely, granularly trying to divide that segment. It's a whole lot of segment. It's only 20% which has other classes, which didn't seem right to us. And secondly, all this information that is given via throughput of NetInfo API, it is capped at 2 Mbps. So for some use cases, not for the image per se, but for some other use cases, it will be very useful for us to know something beyond 2 Mbps, let's say for uh, live videos and things like that. So that was another thing that was a little bit limiting. And um, another limitation that we saw is there was a significant difference in the distribution. Let's say we plotted NetInfo's data, RTT and throughput, and our own way of computing this information using the network requests that go out of LinkedIn.com using, let's say, resource timing entries, and we compare both. There was a big difference in the distribution, and that was at least that our understanding is NetInfo is a global API that uses requests from all the domains to derive this information, whereas what we did was mainly to use LinkedIn's API data only. And secondly, NetInfo combines both data centers and CDNs, and their performances are very different. So we wanted a special we want to separate them because we have some use cases which are image focused, media focused, that are driven by CDN performance, and there are some APIs and other use cases which are driven by data center or POP performance. So we wanted that type of differentiation in let's say the API we build. And finally, it's a very important point. Honestly, one of the prime motivations for doing this is NetInfo covers the network aspect, but we also wanted something that covers the device aspect. And we have the gold standard metric, page load time, which covers both, at least for server-side rendered applications like Lite. So we wanted to use page load time instead for all our work. That's why, so that it covers a big experience aspect of entire users and not just network. So because of all these things, we built this service called Performance as a Service and rolled it out at LinkedIn. However, it's pretty hard to do this honestly because deriving what members say as good experience and bad experience is a very tricky and subjective thing. What's good for me may not be good for, say, others based on their expectations and uh, like use of LinkedIn.com. And doing this in real time, like just when they go to LinkedIn.com, we would like a classification. It's not after the page load has happened. We would like to know this as early as possible, this classification as good, bad, or average, so that we can make decisions on the server side. So is it possible to even build something like that? And finally, we would like to have this for every request, not just the future request. We would like it to be there from even the first request of LinkedIn, like of all of our members. So uh, I mean, I can go into a lot of details for all these three things, how we solved it using machine learning. But at high level, I can give you this summary in one slide. If you are more interested, we have a blog which thoroughly goes through all these details. Uh, but what we want is this classification, which is good, bad, or average, using page load time because it represents the entire end-to-end member experience. And what we get or what we have at network request time or request time are these things. So we can derive the geography information from IP address. We can derive some network information again from IP address like ASN, POPs, the data center, and all that. We can derive device and browser information from user agent. So we have these things whenever someone makes a request, but we don't have page load time or a classification that we can do on top of these things directly. So we built a model and trained it offline using historical member data that we obtain via RUM, and RUM is real user monitoring, and try to understand the correlations of how all these features map to these classes. And it's a very complex correlation, and that's why we needed a very complex model to make this happen. And after doing that, we got some pretty amazing results as well. So just like we expected, these results were much better than what we saw with NetInfo. Uh, so again, the feed viral actions improved, like even the people who were engaged improved and revenue also improved. These are all very tough metrics to move without adding new features. And we were able to do it only by changing the image resolutions. And this is just one use case. There are so many other things we can do with this service. Now, but again, like I said, it's a very complex model because these are very granular or not so granular features that I described, like device type, operating system, OS version, and just deriving page load time from those is a hard task. And we used a deep neural network to do this. And we tried other approaches like other simpler modeling approaches, but they didn't give us as much performance. And we have a blog describing more details on why machine learning and why deep learning if someone is interested to read about. And this model, like as shown here, takes these informations that we get from IP address, user agent, and um, yeah, mainly those things, and returns something called a performance quality class. It returns good, bad, and average, and the probabilities of each class. So we know that it is hard for other say teams and companies to get the fund to get sometimes funding and also to build models at this scale, because we are lucky to have so much data at LinkedIn. So we wanted to give back to the community and get some feedback. So we are planning to open source this model soon, and we'll have an entire blog written about it, why we think this model is a general model that can work for many companies who are also as server side rendered based. And once you have that model, the next big question is how do I deploy that model as a service and use it, right? So we are also writing another blog post on our collaborations with the TensorFlow team and how we deployed that model using simple JavaScript functions and APIs using the TensorFlow JS offering. And this is using Node.js, so it is on server side. And a small, I think, insider information. the results were amazing. So I think just we are also very eager to publish it very soon. So we are working with them. That's it. Yeah. Thank you.